Now let's see this question. This question came in Gate 2015 for 2 marks. Okay. The question is, the graph below has 8 edges. Okay. So we can see here that this is a graph where 6 nodes are there and 8 edges are there. Okay. And there are, and it is given that the edge weights are distinct integer edge weights, which means that they all are distinct first of all, and they all are integral values. Okay. The minimum spanning tree MST is of weight 36, and what is that? That is basically constituted of these edges: AC, BC, BC, BE, EF, and DF. Okay. So uh, this is the MST. This is the MST of this graph. Okay. So how many vertices are there? 2, 4, 6. 6 vertices are there. So basically n is equal to 6. How many how many edges should be there in the MST? N minus 1, which is 5, and that's why 1, 2, 3, 4, 5. 5 edges are there in the MST. Okay, let's go forward. The edge weights of only those edges which are in MST, only they are given. See, 9, 2, 15, 4, 6. So only those edges which are part of the MST, only their edge weights are given. Okay. The minimum possible sum of weights, minimum possible, this is important, the minimum possible sum of weights of all 8 edges of this graph is what? So basically 8 edges are there, and 5 are already here. We have to find the values of these 3 edges. That we have to find the edge weights of these 3 edges. So let's name them A, let's say B, let's say C. So A, B, C, these values we have to find out that what are these values, what are the edge weights of these values. Okay. So let's start with this. Now, what is the value of A going to be? See, what do you think the value of A is going to be? If A is, let's say, 1 or something like that, then smaller than 2, then why do I need to have this 2 in MST? I will simply have AC and AB, and that's it. I don't need to have this. What about if it is something like 8 or 7? Then I don't need to have AC. I will have BC and AB. That's it. It will be 8 and it will be 2, and this will be a smaller MST, right? I don't need this. So my point is that whatever is the maximum of these two, 2 and 9, this A must be bigger than 9. That is my claim, because of the explanation I just mentioned. Now you can see it in another way also. See, if we are creating this MST using, let's say, Kruskal's algorithm, then what happens that if there is any loop, then what happens? We are going to we are taking smaller edges, and then whenever there is a loop, then we are not going to take that edge. Okay. So if it is something like 9, 2 and 11, then okay, 2 we will take because it will add a new unvisited edge, unvisited vertex. Similarly, we will take 9, it will add a new unvisited vertex A. After that, we will just simply not take 11 because it is going to create a loop. Okay. Moreover, it is not going to give us any unvisited vertex. However, that is not the criteria. We simply keep on taking the unvisited. We simply keep on taking the minimum edges in Kruskal's algorithm as long as they do not create a loop. So we simply have to see that whether that is going to create a loop or not. Now my claim is that if that is going to happen, then whatever the edge is going to be, which is left out, that must be maximum, and that's why that was not picked up in the Kruskal's algorithm as a part of the MST. Okay, so that also justifies that whatever the two earlier edges are there, definitely this must be the bigger of all 3. That's why this must be bigger of these 2. That's why it is going to be bigger than 9. But what is bigger than 9? Can it be 9.5? No, because it is. And can it be 9? No, because it is said that distinct. Also, it has to be integral. So it has to be 10 only. So A is equal to 10. That is the only option. Okay. Now let's talk about B. Similar to here, we will not do that much analysis. Here we can simply see that as what we did here also a loop is being made, and this will be bigger than the bigger of 4 and 6, which is going to be B is bigger than 6, which implies that B is equal to 7, because it is the next possible integer. Only that edge weight is possible. Okay, what about C? Now it is interesting. See, if we would not have taken this BE as part of MST, then that would only happen if this C is somewhat, let's say, smaller than 15. Let's say it is 10, 12. If 10, 12 something is the value of C, then what is the need of taking this one? I will simply connect this part and this part of MST with CD, and that will give us a smaller MST. And that's why I will not take BE as part of MST, which means that if it is given that BE is the part of MST, then this must be bigger than 15, and that is the claim which I am going to make. C is bigger than 15, but it cannot be 15.5 or something. It can only be next integer. It has to be distinct and it has to be integer. That's why C is going to be 15. That's it. We just sum it. Sorry, C is going to be 16, the next possible integer. So we are going to sum it 16 and 10 and 7. So overall it is going to be 10, 7, 17 and 16, which is going to be 33. Okay, so 33 is sum of A plus B plus C. A plus B plus C is equal to 33. Now you have to find the sum minimum possible. So this is the minimum possible value of A plus B plus C. That is done. But we have to find the minimum possible sum of weights of all 8 edges. And other edge weights are given, they are constant, right? They cannot change. So simply we sum other ones, 6, 4, 10, 15, 10, 25, 25 and 9 to 11, 25 and 11, 36, right? 36. And that is going to give us 69. Okay. So our minimum possible value of the sum of all the edges is going to be 69. 69, and that is the answer.